So let us program a linked list in C++. So a linked list is a head pointer and a tail pointer, and in between we have the nodes. The nodes hold the data, and in each node there is a pointer that points to the next node. So in this linked list we are going to add the methods add before, that adds a node at the beginning of the list, add after, that attach a node at the end of the list, and get value at index, which get the value of a node at some index. Okay, let's start. So we will use templates that allow us to create linked list on different types. I will start by creating a class linked list. We have private member and public members. Okay, so we said that the linked list is composed of nodes. So we have to create the node class. Again, the node is composed of private members, public members. In the private member, we said we have a pointer that points to the next node. So let's call it next node putter. And there is the value. And I'm going to use a pointer that points to this value. So when we construct the node, we want to construct it by passing a value to it. So we delete the default constructor and we create a constructor that accepts a value. And right now, the value pointer shall point into the value. So we create a new object of this value, and the value pointer is gonna point to it. The next node pointer shall point into a null pointer, because we didn't we link the nodes together inside the linked list, but to link the nodes together we need methods in order to expose this next node pointer. So we need a getter and we need a setter. So void set next node pointer, and it's gonna accept a pointer, right? So we're gonna say here next node pointer is equal this past pointer, and then we want to get the pointer into the next node. And here we have to return the private member next node pointer. And finally, we need to get the value, right, from the node. And in here, we have to return the value by dereferencing the value pointer. But mind you, sometimes if value pointer is null, then what's going to happen? We need a way in order to communicate that this node doesn't hold any data. And there is a nice feature of C++ that we can utilize, which is optional. And to use optional, we have to include the header optional, and then we say if value pointer is null, then we return std null opt. Okay, right now we can test our node. This is the node. We create a node of int and we pass a value of 3. And then here we can print the value of the node, for example. Node object created with value. And then we have to do node. We call the method get value, but mind you, get values can return back an optional. So to get the value from the optional object, we have to use dot value. Right now we can compile. Oops. G++, linked list.cpp. We compiled, we tried to run it, and node object created with value 3. So this is what we expect as an output of our program. Right now, let us program the linked list. As we said, the linked list is a head pointer and a tail pointer. So that head pointer shall point to the first node in the linked list. The tail pointer shall point to the last node of the linked list. So let's do it. So a pointer into a node, right? This is pointer into a node, and it's the head pointer. Then there is a pointer into the tail. And finally, I'm going to add an integer that gives me the size of the linked list. Right now in public, we need the constructor. So in the constructor, in the beginning, the head shall be null putter, and the tail shall be null putter until we start adding elements. Then the size, the initial size is 0 because there are no data inside this linked list. Then we need the destructor we implemented later. By the way, we forgot to add the destructor into the node object. This is very important, otherwise you will have a memory leak. And here you do delete value pointer. But what happens if value pointer is null pointer? So if it is null pointer, we return. Then we return. So I already have a dangling memory, ghost memory, after I executed my program because I forgot to use the delete to delete the memory that is pointed to by this value pointer. Anyhow, right now we fixed it. So in the linked list, as I said, the destructor we are gonna implement it later, and it has to delete all of the nodes that we add into the linked list later in our program. So right now I'm gonna implement the add before method that allow us to add values into this linked list. And before, so we add a value, so a t value. So what do? We have to create a node called the new node, and it is a pointer to this new node because creating pointer. I'm going to use the new operator, and I'm going to create a node of type t, and as we said, We want to create the nodes by passing a value. Then as before, as we said, we are going to stick the node into the beginning. So how do we do that? You add the node into the beginning and then you link it to the first node and then you move the head into this new node. Then we are going to stick it into the first node. How do we do that? We have set next node pointer and it has to be equal to the tail, right? Because, sorry, to the head, because our head points to the first node. Then we have to move the head into the new node pointer. But mind you, this works when we have elements inside the linked list. But consider this. In the beginning, when the linked list is empty, the head is going to be null pointer. So we're going to say if head is equal null pointer, then what's going to happen is that the head is going to be pointing into the new node pointer. Otherwise, if there are elements, we do our logic. The same if the tail is equal to null pointer, we will say that the tail is equal to new node pointer. So in this situation, when the linked list is empty, the head and the tail are equal to null pointer, and then when we add the node, the head and the tail have to point into this newly created node. Right now we do the add after method. In the same way, we create the new node and we check if the head is a null pointer. So if the head is a null pointer, we are gonna say that the head should point into the new node pointer. If tail is null pointer, then tail okay. Otherwise, when we add after, we have to link the last node into the newly added node, and then we move the tail into the newly added node. So we have to say tail set next node footer to the new node footer. Then finally we move the tail the newly created node. Like this, we added nodes to our linked lists. So right now we have to delete those nodes. We can delete the nodes through the pointer, the head pointer. So if we do like this, we delete one node, but then we lose track to the other nodes because we destroyed the node. So if we do like this, we destroy this node, and then there is no way that we can retrieve the other nodes, because when we destroyed this node, we destroyed also the pointer that points into the others. So what we have to do is we have to store this pointer in memory. Then we do node t temp, we call it head get next node footer. Then we delete the head. Then here we assign the head into temp. So this is the whole idea. So we delete this node and we move the head into the next node, and we do it all over. So to be able to loop on all of those nodes, we have to use the while loop. We say while head is not equal to null footer and this is how we destroy the linked list. Finally, we can try. We say linked list ll, and this will construct the linked list. Let's try to compile. We forgot to use the type. Declare the type, so the linked list will have elements of type int. Everything is okay. Right now we have to add the elements. So let us add some elements. We use a vector in order to add the elements, to store the elements. So you use include vector, and to say the elements that I'm gonna include are like 1, 5, 6, 2, 3, and then we can loop all over the elements, and we can add them into the linked list. And we do add after. Right now, we try our program. We hope that nothing crash. Okay, everything is okay. So we created the linked list and we are able to add values into it. Now let us retrieve those values. How to retrieve them? We implement a function get value at index, and it takes an index. Now, what are we going to do is we are going to loop over the elements till we reach into the index, and we retrieve the value of the node at that index. So the index of the first node is 0, then 1, then 2, then 3, then 4, and this is how we do it. So first we need a node pointer head, and then we loop all over the nodes. Return node get value. So this is how we do it. But first, we have to make sure that there are elements inside our linked list. So if the size is less than or equal to 0, we have to return std null opt t optional. So if there are no elements, we have to say, okay, there are no elements. So we return back this null opt, saying that there are no elements inside. There is no element at this index. Now, if the index is more than the size -1, then also return std null opt, because the index starts from 0 till size -1. And I forget to do something here. We have to add size, right? Also, we have to add to the size when we add before and after elements. And if index is less than 0, so we return std null opt. No, I made a mistake here. So we have to move, we say node equal node get next footer. Sorry, there is a mistake in here. And finally we return node get value. So let's right now print the elements of the linked list for I equal 0, true, then I plus plus. This is going to give us an infinite loop. So we use auto opt equal ll dot get value at index, and we use I. Then we check if there are values, if opt has value. So if there are no values at that index, what do? We break, because we reached the end of the list. Otherwise, we retrieve the value, dot value. Then we print it, cd cout linked list value at index I is value. Let's try our program right now. Yeah, because get next node footer. Voila, it worked. We can also try add before. instead of add after, can do add before. And we test again. So we shall get 3, 2, yeah, so it's in the opposite order. Let's try. Okay. We got the vector in the opposite order. 3, 2, 6, 5, 1. And that's it, folks. Bye-bye.